Alright guys, so previously we were looking at this question, BMAT 2016 question 12, working out the internal cross-sectional area of this artery. But now guys, we're going to move on to a different question, BMAT 2014 question 12. This is in a town, the bearing of the library from the station is X. The theatre is due east of the library. The theatre and the station are equidistant from the library. And says, what is the bearing in degrees of the station from the theatre? So guys, give yourself a minute. Be sure to be back after that minute. And then we're going to go over the solutions. Okay guys, so let's go over this. So we're told here then that the bearing of the library from the station is X, and that's already shown. The theatre is due east of the library, which is already shown. And then the theatre and the station, so the theatre, which is this, and the station, which is this, are equidistant from the library. So they're the same distance from the library if you join them point to point. That means that this length here, I can call that Y, and that should be equal to this length here, because they're equidistant. That should also be Y. And it says, what is the bearing in degrees of the station from the theatre? So we're basically dealing with bearings. I don't think we've done this before. So the way you deal with bearings is wherever you're going from, so in this case from the theatre, you draw a north line going from there as the first step. And then where are you going to? You're going to the station, so theatre and station. So you draw a line connecting the two, so this dotted line here, right? And then the way you work out the bearing is you go from the north line, and then you go clockwise until you hit the line adjoining the two things you're considering. So that this is basically what we need to work out, this question mark, how many degrees that is. So the first thing you can do, guys, is actually work out what this angle is here. Because remember, guys, when you have two north lines and a line connecting it, basically what we can see here, this, the Y, and this again, the two angles in there should add up to 180 degrees. So this angle I've shown highlighted here should be 180 minus the X, right? Then I can work out what this little angle is here, because it's part of a circle with that 90 degrees, isn't it? So the 90 degrees plus the 180 is going to be 270 minus X. And then the whole thing has to add up to 360. So that angle in here, therefore, must be 90 plus X, isn't it? That has to be 90 plus X, right? Now, the remaining two angles, since the angles in a triangle have to add up to 180 degrees, the remaining two must be 90 minus X, right? But then this is an isosceles triangle, isn't it, guys? Because the Y and Y is the same, right? So I'm talking about this triangle here. So that's an isosceles triangle. So each of the angles, so this one and this one, have to be 90 minus X divided by 2, right? And to work out what the question mark is, it's just going to be, it's a circle, so you got 360 minus the 90 minus X over 2 firstly, right? So you have, that's this, and also this 90 degree that you have here. So plus that 90 degrees you have in there. And then that should give you what the question mark is. So there, just doing a bit of tidying up, you should get 90 over 2 is going to be 45 minus X over 2 plus 90. Then you get 360 minus 45 plus 90 is going to be what, 135 minus X over 2. And then you get 360 minus 135, which is going to be 225. Yep, so you got 225. But then remember, be careful here, guys. Minus X over 2, that's going to be plus X over 2. So then the answer you should get, guys, then is F. So hopefully, guys, that has made a lot of sense. And as always, we look forward to seeing you in the next video. Alright guys, so previously we were looking at this question, BMAT 2014 question 12, where we were dealing with bearings, a new topic we haven't really covered before, but hopefully guys, with that explanation, this was a semi-tough question. With that explanation, guys, I really hope the topic has made sense, and I really hope the application of that to BMAT questions has also made sense. But now guys, we're going to move on to BMAT 2012. So this is the design in the diagram is formed from 4 circles which all touch at the top of the shape. The diagram is not to scale. There's the diameter of the smallest circle is D, the second 2D, the third 3D, and the largest is 4D. And it says write an expression for the area of the shading in the design. So guys, pause the video, give yourself a minute, be sure to be back after that, where we're going to be going through the solution. Okay guys, so let's go through this. Right, so we know here then the diameter of the smallest circle is D. So basically what they're trying to say is this is D, and I think the next one is going to be here, right, etc. So you got 2D here, and then with this shape here, from there to there, let's just say you got 3D, and then the biggest one, let's just say something like that, is going to be 4D, right? And we're basically told to work out the area of the shading. So let's start with the big shading here first. So with the big shading over there, is just going to be the biggest circle minus the second biggest circle. Remember, the area of the circle is pi r squared. So basically, we've got pi. So the biggest one's going to be pi. The radius is going to be 2d. Remember, the diameter is 4d, so the radius is going to be half of that. Squared minus pi. And then you're going to get 3 over 2d squared. Right? So that's going to be pi lots of 4d squared minus pi lots of 9 over 4d squared. Right? And then just brushing this up a bit, I can say take out a factor of pi. I'm going to write the 4 as 16 over 4 d squared minus 9 over 4 d squared. And then brushing that up, you're going to get 16 minus 9 is going to be 7 over 4 d squared. Right, so that's that. Now to find the next shading, it's just going to be the second minus the first circle. So the first smallest one and the second smallest one. So this one here is going to be pi d squared, which is the second smallest, right? Because remember the diameter is 2d, the radius will be d, minus pi times half d squared. That's going to be pi d squared minus pi lots of a quarter d squared. And then if you brush this up, you're going to get 3 over 4, basically, isn't it? 3 over 4 pi d squared. Now you just need to add this to this. And if you do that, you'll get 10 over 4, isn't it? Yeah, 10 over 4. So 10 over 4 pi d squared, which is equivalent to 5 over 2 pi d squared. So that, therefore, guys, would give you A as the answer. So again, guys, as with the other questions, I really hope this question has made a lot of sense. And as always, really look forward to seeing you in the next video. Alright guys, so welcome to the next video. So previously looking at this question, BMAT 2012 question 4, working out the area of the shaded regions here. Again, compound shapes, a really common topic in the BMAT, so something to not miss out in practice. But now guys, we're going to move on to the next question, BMAT 2010, question 16. It says a shape is formed by drawing a triangle ABC inside the triangle ADE. BC is parallel to DE, and you have lengths AB is 4, BC x plus 3, and x minus 4. And it says calculate the length of DE. So guys, pause the video, give yourself just a minute, and be sure to be back after that. We're going to go over the solutions. All right, guys, so welcome back. So let's annotate this diagram. So you know AB is 4, right? We know BC is x, right? We know DE is x plus 3. We know DB, so BC should be here. So BC is x, and then DB is x minus 4. Right? So this more or less, guys, is just a congruency question. So if you draw, this is ABC, right? So this is ABC, and the next one's going to be ADE. So this is triangle here, ADE. And obviously this, to get from this to this, you're just timesing by a certain scale factor, which we basically have to find out. So the way we can find this out, guys, is that we know that this AB is 4, and A to D is going to be x minus 4 plus the 4, right? Which is just going to be x. So the scale factor from there to there basically is just x divided by 4. And we need to calculate what DE is, right? So we know that BC is x, right? So we know that BC is x. And what else do we know? AC, do we know that? No, we don't. And what we know that DE is x plus 3. Yep. Is there anything else we know? Okay, that's more or less all we know. And also, what we also know is that the scale factor, we can also work out the scale factor between DE and BC. So that's just going to be x plus 3 over x. And that should be the same as x over 4, because there's just going to be a common scale factor which is going to enlarge the whole thing, isn't it? And then if you just play around with this, you'll get 4x plus 3 equals x squared. And then you get 4x plus 12 equals x squared. You get x squared minus 4x minus 12 equals 0. And then if you solve this, you can put x minus 6, x plus 2 equals 0. And then from this, x equals 0 and x equals minus 2. But since x is the length here and the x can't be and the length can't be a negative number, x must be 6 then, right? Then to work out what DE is, then you just do x plus 3, so 6 plus 3, which is basically 9. So that's how you get your answer C. So hopefully, guys, that has made sense. Can you see, guys, a bit of algebra, a bit of measure, a bit of geometry, quite a few different topics mixed in this question. But this is common in BMAT Maths, and it's really important that you get confident with this. But I'm sure, guys, as we move along, your confidence will build, and that's a good thing. So see you guys in the next question. All right, guys. So previously, we were looking at BMAT 2010, question 16, more or less a congruency question mixed in with a bit of algebra. But I really hope, guys, that question has made a lot of sense. Now, guys, we're going to move on to the next question, which is BMAT 2009, question 20. So it says, a solid sphere of radius r fits inside a hollow cylinder. It says the cylinder has the same internal diameter and length as the diameter of the sphere. And it says the volume of the sphere is 4/3 pi r cubed when where the radius is r. So what fraction of space inside the cylinder is taken up by the sphere? So guys, pause the video, give yourself a minute. Be sure to be back after that. We'll go through the solutions. All right, guys, so welcome back. So here we have a solid sphere of radius r fits inside a hollow cylinder. So let's just say this is the cylinder. A hollow basically meaning the inside is empty, right? So we have that, something like this. And then, so a solid sphere fits inside the cylinder, has the same internal diameter, and the cylinder has the same internal diameter and length as the diameter of the sphere. So basically, it fits in perfectly, is what it's trying to say. So I'm not sure how nice this is going to turn out. It's probably going to look more like a rugby ball. But if you just imagine that's a sphere basically, yeah. And then we know that the sphere has radius r, right? So this is basically radius r, right? What fraction of space inside the cylinder is taken up by the sphere? So basically, you have to work out the volume of each, and then work out the ratio between that. So let's so the volume of the sphere is more or less already given to us, isn't it? That's just that, more or less. And then we need to work out the volume of the cylinder. So I'll just call that VC. So VC is basically going to be, so remember, a cylinder is just a prism. And the way you work out the area of a prism is the area of the cross-sectional area, cross-sectional surface area. So that's going to be the circle there, so pi r squared, times the length. So the length is just going to be 2r, isn't it? Right, because you have r there and you're going to have another r here. And then if you do that, you're going to get 2 pi r cubed, right? And then what you want to do then is 4/3 pi r cubed over 2 pi r cubed, right? So that is going to cancel out. And then if you fiddle around with this, you'll get 2/3 basically. And therefore, the answer you're going to get, guys, is D. So hopefully, guys, that wasn't too much of a problem. And as always, we look forward to seeing you in the next video.